Okay, today we're going to look at the inverse matrices and the determinant matrix. So what an inverse matrix is, if we have a matrix, say matrix A, an inverse is written matrix A to the power of -1. And another way we can write the inverse is saying 1 over matrix A. So say, for example, we could have lots of things that are inverse. So say we had, that's the inverse of X. It actually means we have 1 over X. And then if we had 3 to the power of -1, that's the inverse of 3. So what you can see, it's like when you have the inverse, it's a way of dividing. So what we're going to use is when we multiply a matrix by an inverse, it is a way of dividing in matrices. So it is a way of dividing in matrices. So if we go through first, so let's have a look at our inverse. So as we said, the matrix, the inverse matrix is written with that -1 up the top. Now it can only be a square matrix, so that means the same amount of rows as columns. So it could be a 2 by 2, 3 by 3, etc. So that's a square. Now, if you multiply a matrix by its inverse, you end up with its identity. So if I come over here into our calculator and I show you an example. So say I had this matrix, I'm just making it up. So I had this matrix here. Now, to find its inverse on the calculator, all we have to do is raise it to the power of -1 and you press enter. So this one over here is the inverse of the original one, which is 2, 3, 4, 5. So what we're saying, if we take the original matrix, this one, so I'm just going to, without the inverse, so this original matrix, if I take that one and I times it by the inverse one, so there, like that one, what we end up is with the identity matrix. So if I press enter, you'll see it here. So we see that we have the ones on that leading diagonal, and we get an identity matrix. And that we would get the same in real life. If we took, well, like real numbers, whatever, if we took 3 and we multiplied it by its inverse, which is 1 over 3, we end up with 1. And that just, so if you times anything by its inverse, you get 1, and the same within matrices. If we times the matrix by the inverse, we don't get 1 as such, but we get the identity matrix, which is like a number 1 in matrices. So if when we are calculating the inverse, we use a number, there's a number that's found called in the calculations called the determinant. Now, if this determinant becomes the number 0, we cannot get an inverse. So I'll show you that, like what we could have over here. So I'm going to show you here. So if we can have this matrix here, like this. So if I try to raise this one to the power of -1, you'll see, oh, sorry. It would help if I do it. Sorry, not that one. If I change, sorry, the determinant didn't equal 0 in that example. So I wanted, what do I want that one to be? 3. And I want that one to be 2. Oh. Sorry, so if you take this one, for example, if I try to raise it to the power of -1 and find the inverse, you'll see here, you get an error. You can't be done. This is because this matrix here has a determinant of 0. So let's go work out how we can find the determinant. Now, we have to find the determinant of a 2 by 2. We need to know how to do that manually. All other ones we can do we'll use our calculator. But a 2 by 2, you do need to understand how to get the determinant. So here's the rule for a determinant of a 2 by 2. So say you have this matrix A here, and you have a number in the spot of A and a number in the spot of B and C and D. If you're going to find the determinant, we're going to do that A spot multiplied by the D spot minus the B spot multiplied by the C. So down here with this G, if I was going to find the determinant of G, and we often write it like that, so what I'm going to do is this spot multiplied by that, so it'll be -3 multiplied by -7, and then we subtract, because you can see the rule says subtract, minus the other spot, -9 times 2. Okay, so what we've seen is we do this number multiplied by that number, then this one times that one, and taking away that. So when we do that, we end up with, this would be positive 21 minus and minus 18. So we're going to end up with 39. So there I can do it manually on my but if I was going to just do that one on the calculator, all you need to do is type in the DET, then you put the curve bracket, which is that one, then you pop in the matrix that you want to find the determinant for. So I've got -3 there, -9, 2 and -7. So if I press enter, I end up with 39, which is what I got. So that's how we can find the determinant on our calculator. And we would do that for all big ones, like bigger than a 2 by 2. So if we had a 3 by 3, etc. Now, this is all leading into finding the inverse manually, because that's another thing we need to do. So we need to be able to manually find the inverse of a 2 by 2. Otherwise, all bigger ones, we can just use our calculator. But we may get asked to show all the working out of that. Now, you can see, like what I said, down here in the formula for the inverse, there's the determinant. Now, so you can see on the outside, we have this scalar number here. You'll end up with a fraction. You'll put 1 over the determinant. So for before in the example, it would be 1 over 39. Now, this is why, because if we're looking at the formula, is why we can't have a determinant of 0. If you look back over here on the calculator, if I was just going to write a fraction and I put 1 and I try to put 0 on the bottom, 1 over 0, you press enter, you'll see the calculator says undefined. So that's why we can't have a determinant of 0. If I have any other number on the bottom, and it doesn't matter, I could have a negative, that's fine, and so on. So the determinant just cannot be 0. It can be any other number. Okay, so then we keep going on with our inverse formula, and what you'll notice is these two numbers swap position, and the other two numbers become negative. So let's do an example down here. It says manually find the inverse of matrix A and B. So first of all, we're going to find the determinant of A, and we're going to have, it's going to be 5 times the 6, so this spot times this spot, minus the 2 times 3. So that's going to be 30 minus 6, so it's going to equal 24. So now when I go to find the inverse of matrix A, I have to do 1 over the determinant, which is 24, and then I'm going to swap these two numbers. So 6 comes up here, 5 goes down there, and I make the other two negative. Okay, so that's that far. Now this number out here is what we call a scalar. And if you remember when we said when we had them, when we want to multiply by a scalar, we multiply everything inside the matrix by that scalar number. So I've got 6 over 24. I'm multiplying them all by 1 over 24. So essentially what you see is all the numbers over the determinant number. And then obviously they could be simplified. And if you simplified them, you would end up with 1/4, 1/8, negative a 12th, and 5/24. So just to check that I'm correct, I'm going to pop that matrix over here in the calculator, matrix A, and I'm going to check that that's what my inverse is. So I'll put it to the power of -1, press enter. So you can see over here, we have the same matrix that we have here. All right, let's give a matrix B a go. So the determinant of B would equal -3 by -2 minus 7 times 2. So we end up with +6 minus 14. So we end up with -8. So then to find the final inverse, I do 1 over the determinant. I swap those positions around. So -2 goes up here, -3 goes down there, and I make the other ones negative. If they were already negative in the original matrix, they become positive. So you're pretty much changing the sign of those two. So then we would multiply that scalar out, and I'd ended up with -2 over -8, -7 over -8, -2 over -8, and -3 over 8. Now, if I simplified that into simplified fractions, I get 1/4 here, 1/4 here, 7 over 8 here, because the negatives are both making it a positive, and 3 over 8 here. So let's quickly check. Gonna pop in a square matrix, pop in that matrix B, and check, raise its power of -1, press enter, and there we go. We've got 1/4, 1/4, 7, and 8, and yep, that's the same. So that's finding the inverse and the determinant manually of a 2x2. Otherwise, we could just find them on the calculator. So just to have a little practice of the determinant again. So say I wanted to, I'm just copying and pasting. Say I wanted to find the determinant of this one. I'm going to write DET, curve the bracket, have a curve bracket, then the matrix, press enter. Now we found that to be -8, and there it is.